Okay, part 5. We're going to get more into functions. We've talked about functions before, but just briefly. So we're gonna learn 8 new things about functions here, and I have them all listed. If you forget, you can come back and look at this. But let's go ahead and get into VS Code and look at this code here. Okay, so thing 1, functions can have default arguments. So here we have an add function that adds 2 numbers together. The second argument we're calling y, and we assign y in the function definition to 2, and that means we're saying if the caller does not define y, then assume its value is 2, and we see this down here. When we add just 1 and don't supply a value for y, we get 1 plus 2 equals 3. But if we do supply a value for y, it uses this value instead, so we get 1 plus 5 equals 6. This is pretty important, and it's used all over in Python code. And one of the main reasons is it's always a good idea to give your code reasonable defaults for certain things, especially configuration values, that kind of thing. It can just make your libraries easier to use. Okay, item 2. If functions do not return anything, like there is no return statement in the function, their return value is none. So you'll see here we have a new keyword called pass, and this is equivalent to just white space. But in Python, white space is important. We couldn't just do this because this won't parse, because when Python sees a function defined, it expects an indented scope under here. And so in Python, if we want to just define an empty scope, we can just say pass. Now, this is functionally equivalent to defining it this way, saying return none. They both return none. So both of these assertions evaluate to true. Okay, item 3, let's go ahead and let's do a breakpoint here. Jump into the code. Start a terminal. All right, let's go module 2. All right, so we're on line 44. Item 3, functions can return multiple values. You'll see that we have 3 values separated by commas here, part of this return statement, and here we're assigning these 3 values like so. This works. This is totally fine Python. It might look a little weird if you're coming from some other languages. Not all languages support more than one return value. We'll get into how this is actually working later when we talk about tuples and lists. But just know that this is valid. But if you are going to unpack multiple values into multiple assignments in a function call like this, you need to be sure that the number of variables you're assigning to equals the number of variables that it's returning. So let's look at this. We have 2 options. We could return all of these into a single variable, or each to each. But if we do each to each, we need to make sure the number is correct. So let's see what happens if we try to do something like this. var1, var2. Yeah. We'd say this function returned too many values to unpack because our assignment expected only 2 values. However, we can do this. This is perfectly okay, because we're assigning all 3 values to a single variable. Again, we'll get into more of what's going on here later, but just know that you can do this, and this is valid Python. Okay, item 4. And this is also pretty important. Function arguments can be passed by name. So we have a function here, lots of args, and it takes 4 arguments. and they're called W, X, Y, and Z, and they all have default values. So let's go ahead and move to line 55. So lots of args is defined. Since they all have default values, that means we can call lots of args and not give it any values, and it'll just use the defaults for all. And you see that lots of args just returns our parameters, so returns the defaults here. Now, a lot of functions might accept a lot of parameters, and a lot of those parameters might have reasonable defaults, and you might frequently find yourself in a situation where you want to call a function and you only want to tweak like one of those values. It would be very verbose if you had to also supply all of these leading values to get to be able to supply this last one here. So like that's how this would look. And you know, we're just having to duplicate these defaults here just so we can pass a different value for Z. In Python, you can also call lots of args and name the parameter you're passing in. So these two calls are equivalent. Down here, it's going to use the defaults for X, W, X, and Y, and then Z we're changing. All right. Thing 5, let's go ahead and move down to line 100. Okay, so two things going on here. First, functions can have doc strings like modules. This triple quoted string right here by convention is considered the doc string for this function. And this is useful because a lot of documentation services, you know, Sphinx being one, will look at these strings when generating documentation for the internet or wherever from your code. And let's just go back real quick to the documentation. We'll see what we have down here. So when we run Sphinx doc, it can auto-generate and render this documentation from those doc strings. You'll notice that this text is the same, and this is what it looks like when Sphinx renders this. And there are sort of a convention for defining parameters and return statements. This is just by convention that Sphinx understands. There are other tools that have a slightly different way of defining this. This is sort of like outside of the scope of Python as a language, like how these doc strings are sort of formatted and written. To Python, this is just text. This is just a multi-line string. It is our tooling that infers specific values from how this is formatted. But since we're using Sphinx doc, I just wanted to give you an example of how this might render when you build this documentation to HTML. Okay, let's go back to the code. The other thing that is going on here is that I'm showing a function that has multiple return statements in it. So a return is just a break where the function decides to exit. It has done everything it wants to do, and it wants to return a value. So this function is just accepting one argument, and if that argument is less than 0, it's returning -1. If it's greater than 0, it's returning 1. And if it's neither of those things, it's returning X. You'll notice this, we could have written this like so. But since we're returning from these two statements, the only way we will hit this line here is in the condition that neither of these were true. So this is just like a shorthand way of shortening off that else condition because it's logically equivalent. Convince yourself that this is true. Okay. The other thing that is pretty cool about Python is that you can store functions in variables. And this might seem a little weird at first, like why would you want to do that? You can just call functions from anywhere. Why would you want to store them in a variable and pass them around? This enables a lot of different sort of patterns of programming, and a very specific one that is quite useful is called inversion of control. And this means, abstractly, where you might find this is, consider a website. So the things that websites have to do are all very similar. Like, they have to respond to requests from your web browser and build the response, which is an HTML page, and return that. You don't want to have to reinvent that wheel each time you want to build a new website. And so it's sort of the backbone processing logic that's going on there is going to be the same website to website to website. So inversion of control is a way to sort of reuse all of that business logic and then sort of replace the specifics. And so what I mean by specifics here, you can imagine the specifics are a function that you could pass into that business logic. So it's called inversion of control because, let's say you define a function, you store it in a variable, then you can pass that variable as an argument to another function, and that function is doing a very common thing, common business logic, let's say for building a response to a web query. But the specifics it doesn't know about. You've handed it a function to execute something specific that needs to happen. This might not make a whole lot of sense right now, but you'll get the feel for it as you continue through some of the gateway exercises. There's one gateway exercise where you have to define your own delegate. But we do have just like a simple example here. So remember, we defined add at the top. So here we're setting my function to add. Let's go back here. Let's see, where are we? Let's go ahead and continue to line 111. All right, so add is the function add. My function, did I spell that right? That's because I'm on line 107 right now, so this hasn't executed yet. Let me move forward. 107, continue. All right, here we go. My function, go forward. Now it's executed. My function add. So this is true. My function should be 3, just like add is 3. So now what we're doing here is we have a different function that accepts a function as an argument. And you can see that it's calling the function that we pass in. So we could say apply function add. Oops, haven't defined it yet. There we go. All right. My explanation of inversion of control, if it's confusing you, don't worry. You'll kind of see later what I'm talking about. But right now, just understand that you can assign variables to functions. And you can pass those functions around, and code that doesn't know what those functions is doing can call them. Okay. So here I have an example of you can do what's called binding an argument to a function, and then pass that around. This is pretty useful, but it's fairly esoteric to be concerned with right now. But just know that the standard library has some utilities for, let's say, recall our default value for y we had set to 2. We could sort of rebind that argument on add and set y to 1, and by calling partial, passing it our function and the name of the function, and this has returned add 1. This has returned a function, and we're storing it in add 1. So let's just go ahead and let's go to 126, continue, add 1. You see that this is a partial, but we have redefined the value of y, default value of y to 1. And if we compare that to add, you can see that it's different. Okay, the last thing is that functions can be defined almost anywhere in Python, even inside other functions. And then those functions that define them can return them. And so what's going on here? We have a function called getDelegate, and it accepts a variable. And inside this function, we define two other functions. One is called handleNone, and one is called handleOther. And they do different things. HandleOther returns variable that was passed in, and handleNone returns 0. So we're using the term delegate here very intentionally. So like a function that handles some piece of logic on behalf of a design pattern that's using inversion of control is often called a delegate, because we are delegating some subtask to this function and we're not really concerned with the details. So this getDelegate function is saying, based on what the value of the variable passed in is, give me a different function to execute. So if variable is none, return this handleNone delegate, and otherwise return handleOther. So let's look at what's going on down here. So we are making a function call, and we're passing in none, which means getDelegate should return this function. So when we call this, let me go ahead and advance to 147. You'll see that the return value is this handleNone function here. And since this returns that, we can then immediately call it. So when we do getDelegate none, this is going to invoke this function and should return 0. We could also, do it like this: getDelegate none. And so now delegate is our function, and we can call it like this. Return 0. So just convince yourself that you understand what's going on in these two lines.